The Inner World Beyond the Prism of Senses, Part 3, Color and Its Nature, based on The Inner World Beyond the Prism of Senses by Mohammed Babai. Dear friends, welcome back to our self-awareness series. In our previous videos, we talked about how knowing ourselves is super important before we try to understand the world. The first step is recognizing the channels through which we receive information about our surroundings, our sensory channels. Our body is an integral part of this information, the body we see in the mirror and experience through touch. Before we can examine the world around us, we need to assess the extent to which the information we receive about our world aligns with the reality of the world. Are these pieces of information reliable enough for us to form opinions and judgments about the nature of the world? The focus of today's lesson is a concept that's all around us: color. It's a concept that we deal with in every moment of life, whether we're awake or dreaming. It's so familiar that we often don't even think to talk about it or question it. Color is one of the elements of our world, and the beauty we perceive from the world is highly dependent on these colors. We cannot imagine the world without them. Even when we refer to black and white, we are still talking about color. So even those who are colorblind still experiencing color. In fact, when we try to imagine colorlessness, we can't completely eliminate color. When we try to imagine colorlessness, we usually think of black and white. But colorlessness is more like looking through clear glass where you don't notice the glass itself. The glass has no color. While in the presence of light, we might think of colorlessness as looking through clear glass. In a place with no light, we're more likely to imagine darkness. In reality, when we imagine colorlessness, we often picture a color, whether it's black, white, or the background colors surrounding that absence of color. Have we ever been able to imagine true colorlessness? Color helps us distinguish different objects from each other. Look at me. One of the key elements that helps you to perceive my face and clothes as distinct from each other at first glance is the difference in their colors. Color gives meaning to our world and brings out various emotions in us. From a psychological standpoint, we use colors in our work or living environments to express ourselves. For instance, black is linked to a sense of indifference to life, yellow to extroversion and optimism, and red to enthusiasm and passion. Based on these associations in mind, colors are used in therapeutic, educational, or commercial settings. Many observations and experiments show that colors even influence our beliefs and judgments. Research has proven the impact of colors on our perception of time, as people in a room with red color felt time passing more slowly. However, have you ever asked yourself, what exactly is color and how does it come into existence? And does the color that shapes our world have any reality? To understand this, we need to examine how we perceive color. In the previous sessions, we covered how the composite eye works. If you need a refresher on what we discussed previously, please take a moment and review session 2. In summary, we learned that photoreceptor cells in the retina are sensitive to light. The pumps in the walls of these cells change shape upon light impact. The changes in the shape of these pumps lead to the generation of a neural signal that travels from the eye to the brain. So the light entering the eye stimulates cells in the visual pathway, and this stimulation is transmitted to the brain through the neural network. The key point here is that light's responsibility ends in the eye. Light merely plays the role as the stimulant for the nerve cells and does not have a direct path into our brain. Now let's take a closer look at this process to understand how we perceive the colors. What is light? In classical physics, light is a form of energy that consists of electromagnetic waves, and in quantum physics, it's conceptualized as packets of energy known as photons. It is said that the difference in waves or photons lies in their wavelength and energy levels. To envision light, we need to picture layers of energy, where the distance between these layers of energy is called the wavelength. The shorter the wavelength of light, the shorter the distance between the energy layers, hence higher energy, and vice versa. In classical physics, light is described by electromagnetic wave, the waveforms that give us an idea of how lights travel through space. The electromagnetic wave peaks at certain points in the space. That energy level reaches its maximum and then gradually decreases to a minimum, and the same cycle repeats, known as a sinusoidal waveform. A wide range of electromagnetic waves exists in nature, from very large wavelength and very low energy waves like radio waves to very small wavelength and very high energy waves like gamma rays. As mentioned earlier, the difference in these waves is in their wavelength. In other words, the building blocks of waves in essence are the same. The only difference is the wavelength or distance between energy layers. But what defines our colorful world, the visible light, is a very narrow range of these vast electromagnetic spectrums, approximately between 420 and 580 nanometers, that can stimulate light-sensitive cells in our eyes. As we mentioned in the previous session, these light-sensitive cells in the eyes are called photoreceptors. In our retina, there are 3 types of photoreceptors, differing in the amount of energy needed to be stimulated. Each type of photoreceptor can be stimulated by a certain range of wavelengths that can be categorized as short, medium, and long. Thus, after light stimulates the corresponding photoreceptor, it stops at our eyes, has no way into the brain, and only serves as a stimulant to generate a neural signal. This is the wavelength or energy of incoming light that determines which retinal cell to be stimulated for sending the neural signal to the brain. But the brain has an interesting way of distinguishing and categorizing messages received from different cells. Color. In fact, color is a label the brain assigns to messages received from different cells to differentiate them. As we mentioned earlier, the energy of incoming light to the eyes determines which cell in the retina is stimulated. It can be said that each color represents a wavelength that reaches the eyes. For example, messages received from cone cells sensitive to wavelengths in the range of 430 nanometers are labeled blue in the brain, and messages received from cone cells sensitive to 540 nanometers are labeled green, and 575 nanometers are labeled red. This is why we say a wavelength of 430 nanometers is seen as blue. From explaining these fundamental principles, it can be concluded that the color we see is formed in the brain and only makes sense in our brain's world. Our eyes are sensitive to waves between 400 and 700 nanometers. This is why only this range of waves is attributed to color and is known as the visible light range. While we float in a space full of various electromagnetic waves, only a small part is perceived as color. For example, radio waves and X-rays cannot be seen with eyes, while radio waves are also made of photons as visible light. If these waves were to have color, we would see them all in one color, with only differences in their intensity. We live in a world full of diverse colors that our brain creates as a result of stimulation with a small range of electromagnetic waves known as visible light. Once again, take a moment to look at the world around us. Light from an object reaches our eyes, the light is stopped in the eye, and a neural message is sent to the brain. The brain interprets this event as the miraculous phenomenon of color. But does the world outside our brain also have color? Do the colors our mind creates exist in the external world? How can we answer this question when our only connection to the world is through waves that are stopped at the eye's aperture? Rumi says in Book 6 of the Masnavi, "The principle of colors is colorlessness indeed. In fact, it seems like two worlds are happening simultaneously, the inner world of beings and the outer world beyond beings." Do we have a way to understand the truth of the external world beyond our minds? While we are only witnesses to signs of this external world, it is not baseless to say that we see in waking, dreaming, and mirage simultaneously. What information do we receive about ourselves? What color is our skin? When even the image we recognize as ourselves is formed in our brains solely due to stimuli received from the eyes, how can we be certain that we are witnessing our true image? To what extent are our beliefs, logics, and judgments based on what we see? Even a significant part of our arguments in self-awareness relies on the sensory inputs. If the foundation of our self-knowledge and understanding of the world around us is sensory channel inputs, we must first understand to what extent we can trust this primary information. Are we truly witnessing inner dreams in wakefulness? We witness a colorful and diverse dream, while the real world outside our minds lacks any color. We are immersed in the world we've constructed, having fallen for the illusion of our own fantasies. Perhaps you might say the world outside our minds may also be colorful. Perhaps the waves, even though they have no way into us, may be carriers of color. Join us to find the answers to this question and thousands of other questions.